cryptography, we have a concept of hashing. So what is hashing? Hashing is essentially if you apply a cryptographic mechanism on a text, and it's an irreversible process. If you get a string or a value which cannot then be reversed back to its original text, this is called as hashing.
I have a
Now,
personal question on hashing. Akshay, sorry to interrupt. Can hashing be reversed?
no, it's irreversible. That's the whole point. And now a follow-up question would be, then what is the purpose of hashing? I mean, if
Yeah.
it's irreversible, then why am I hashing it? So
Yeah.
the thing, love, here is that hashing in itself is basically it's used to identify a text. So hashing in itself is something that is applied. Hashing is associated with, so it's used in a couple of ways, not just in that. A simple a use case, one of the use cases of hashing would be that I will be able to identify this text with the hash that is generated. And the hash in itself says that this string, if I have a string and I apply a cryptographic algorithm and I create a hash out of it, this hash will be uniquely associated with this string. So no two different strings will have the same hash value. So you have an input string and you can convert it into a sequence of characters, a binary sequence. It's irreversible, and you cannot, and the quality of it is that it is, so people claim that it is impossible, and then some researchers academically it is also said that it's theoretically possible. But yes, hashing and to all the incident responders and troubleshooters and information security people out there, this is what we talk about when we say take out a hash. We talk about MD5 hash, we talk about SHA1, SHA256. This is the hash that we talk about, and it's the same. This is the same hash that we talk about. So this is to like the checksum that we say, the way to, I believe I had covered this somewhere in some video or some place in a couple of videos where we talked about love, where we said that it's used to identify and verify the integrity. So a very common example would be when somebody sends you, an information security guy, when he will share a file with you, he will also send the file hash to you. So what you can do is, when you receive that file, you can also generate a hash for it, and then you can verify if the two hashes match, that the file is in fact the file that you received. Okay, so now we are talking about key length. So
this is Akshay, one of the most common questions related topic, key length one, where people are very much confused. I had yesterday also somebody asking me, and I had some other person also who was asking me regarding
I got to know
I think
that.
you were also there in that video, where people have a lot of confusion on key length. So let's be very clear on this, that people get key length as a big takeaway from this video.
So let me just say that I'm going to talk about key length here. So there is a concept, there's a whole different set of questions that practitioners will have. I want to give a disclaimer right now, which I said, the key management part, the life cycle of a key is something I am going to cover in a separate video. So try to ask the specific questions. Wait for that video. It's not going to be very far off. I'm just going to wait for love to just have me for that discussion, because that will be in itself talking about key management in general, because that cannot be clubbed in with this introductory lecture session.
It will be too much.
And it does not make sense. It's too much to consume, believe me when I say this. So the key management, we will talk about everything, but yes, since I understood that a lot of people have been asking about key lengths, I am going to address this in a very basic fashion. So even if you have some in-depth doubts, please wait for that video. Believe me, I will cover this, and I will cover it from the entire life cycle. So I'll discuss the complete life cycle of a key for all different types of encryption mechanisms, and then you can ask as many questions as you want. Okay. So from an asymmetric perspective, so NIST kind of has a recommendation or favors, or let's not say favor, recommends RSA as a good asymmetric encryption algorithm. And so a good question, or a question that comes into people's mind, is how do you determine a key length? Should a public key and a private key be of same length? Who should be smaller, who should be bigger, so on and so forth. So just to answer those questions, I have basis on the specifications created by NIST and the industry standards. This is what the industry is using or following. Is and again, this is specific to you, your requirement, and the challenges you are facing in encrypting your messages and data out there. So what we are essentially saying is that we talked about that the public key and the private key are derived from the same function. So what we are essentially, what why I have written all these jargons is to give you an understanding that this mathematical function has something which is called as a modulus. Now you don't need to understand as a practitioner more than this. If you want to know more about this, there's a whole mathematical equation for RSA. There is a specification. There is, so you can go ahead and read that. I'm not going to cover it here. Uh, what you need to understand as a practitioner or somebody who wants to know about key lengths is that the RSA public key and the corresponding private key, they share a common mathematical structure and a specific value which is called as modulus. Now the what I am saying is that since both these public and private key work over the same modulus value, so the from a technical, diving a little deep, or you want to know a little deep, the strength of the modulus value is what determines the key length of the public and private key. This is the determination factor. Now what happens usually, public key is usually shorter than the private key. For RSA, now hear me out, NIST says that if you are going to implement an encryption mechanism or an encryption strategy that is going to last till 2030, the year 2030, you should use 2048 bit keys. If your encryption standard or mechanism is going to last beyond 2030, because NIST believes that by year 2030, 2048 bit keys will be decryptable and crackable by malicious people. So like we know that MD4 is now not used anywhere, and because it's easily hackable and crackable, that is their projection basis on the crypto analysis that they have done. And if you're using beyond 2030, you have to use 3072 bits. For symmetric, for Diffie-Hellman, as an example of asymmetric, we are saying that the key size may be the private key may be 256 bit, and the public key may be 2048. So what you need, so the essential answer to the question is what kind of key length would be out there. It depends on the kind of algorithm that you're implementing. With the kind of algorithms of the one question is what is being followed in the industry. I showed right now, obviously specific to different, because algorithms are implemented in different ways, so the length of the keys may vary. But this from a Diffie-Hellman, which are the popular Diffie-Hellman and RSA, this is the recommendation. Again, it is up to you and then your risk and on your appetite and your feasibility in your organization to determine the length of the key. I hope this answers your question, or at least gives you a sense of a clarity of about key lengths.
Yes, so it is defined as per the algorithm, right, Akshay, to summarize?
Yes, but for people looking out for recommendations, which I saw quite a number of people were looking out for recommendations, this is here like as a baseline.
Okay, got it.